Okay, so this is topic 4, electric fields. So we'll start off with the basics. So we should know that like charges will repel and that unlike charges will attract. So Coulomb's law essentially is very similar to Newton's law of gravitation. Okay. Essentially says that the force between two charges is proportional to the product of the two charges and the inverse square to the inverse square of the distance between them. So in other words, you multiply the size of each charge, the product of the two will be the proportionality of the force and also the square of inverse square of the distance. So very similar to Newton's law of gravitation. So if you write that out in letters, so force is electric, is proportional to the product of the two charges, and it's also proportional to the inverse square of the distance between them. So if we add a constant of proportionality, in this case 1 over 4 pi epsilon naught, then we get the final equation, the electric field force. So force on, the two charges, the force between two charges is equal to Q1, Q2 divided by 4 pi epsilon naught r squared. Now epsilon naught is a very interesting constant. Essentially it all depends on the space between the two charges, and so we call that the permittivity of free space. So for example, find the size of the force of attraction between a proton, an electron and a hydrogen atom if their separation is 5.3 times 10 minus 11 meters, and that's your normal charge on a proton or electron. So simply just putting it in, F equals Q1, Q2, 4 pi epsilon naught r squared. So you just put the values in, 1.6 times 10 to the minus 19 squared divided by 4 pi times epsilon naught times 5.3 times 10 to the minus 11. So substitute in epsilon naught, you should find your answer. And you'll find it's actually a reasonable size for the size of the object. Okay, electric field strength E is at a point is defined as the force per unit positive charge on a positive test charge. Effectively force per unit charge, which we've done last year. Okay, so here we have a positive test charge placed in an electric field. So remember, the field lines point from positive to negative, and so this positive test charge will be feeling a force in the direction of the arrows. So if we just look at the form we had before, so E equals F over Q, and all you're doing is substituting in the values that we have. So this is all what you've seen last year.